thing we're going to look at now is going to be connective tissue. So a lot of times connective tissue, we can divide it up into a number of different things. In reality, connective tissue is what we're going to talk about today, which is connective tissue proper is what it's kind of referred to as, or fibrous connective tissue. Cartilage and bone are also considered to be connective tissues, as well as blood. So all these things are actually connective tissues. That being said, we are going to focus on, in these next couple of videos here, on what we refer to as fibrous connective tissue or connective tissue proper. So what we're going to see with connective tissue in general is, with very few exceptions, it is really a combination of three major components. You're going to have an extracellular matrix or ground substance. That is the background that's going to house the cells and the other components. Cells actually are not, with the exception of maybe adipose tissue, cells are not the major component of connective tissue. Cells, there's going to be cells present. There's a number of different types they can be. The other thing we'll see is a lot of times they'll change names based on what type of connective tissue we're talking about. We might be talking about a fibroblast with connective tissue proper. We might call that a chondroblast with cartilage, and an osteoblast with bone. That being said, those are similar types of cells. They're doing a similar type of thing. The other basic component of this a lot of times is going to be fibers. So with fibrous connective tissue, this is kind of a bigger deal. A lot of times we're defining what it is based on what type of connective tissue fiber is in there. But it's really almost all these connective tissues, with very few exceptions, are going to be a combination of cells, fibers, and ground substance. And that makes it a lot different than a lot of these other tissues, where epithelium is mainly cellular, muscle mainly cellular, nervous tissue mainly cellular, where connective tissue is a lot more of space, and fibers is what's in most cases can be most prominent about that type of tissue. So we're going to see this extracellular matrix is a combination of those fibers and that ground substance. We're going to see that it's mainly going to be these collagen and elastic fibers. There's going to be some proteins and sugar-based molecules that help make up some of this ground substance or that extracellular matrix. So things like glycosaminoglycans, proteoglycans, glycoproteins. But really a lot of that and the fibers are going to be housed within this interstitial fluid, this extracellular fluid, which is going to have electrolytes, hormones, kind of be a blood filtrate, and what sooner or later a lot of times is going to be taken up into lymphatic vessels to make lymph. So the two main fibers here are going to be the collagen protein. We'll take a look at that, as well as the elastic fibers. Both of them, their microscopic structure, in both cases, kind of show what it is. A lot of times if you look at a collagen protein, it's actually three different molecules that are kind of braided around one another. And if you think about like a braided rope, it's really good at tensile strength, where elastic fibers are more kind of a curled, kind of helix looking type of fiber, which is a lot like a spring, and it is really good about being stretched and going back to its original shape. So collagen, and again, I don't expect you to know all these different types of collagen and where they're at. This was just more than anything really trying to make you aware that there is different types of collagen, and this is why when we talk about collagen fibers, and you're like, well, this is a collagen fiber, this is a collagen fiber, and they can look quite different. This is why. There is a number of different types of collagen. So type 1 collagen, we're going to see, is a lot of that, where we will see it in a lot of our connectors we're going to be talking about today. So things like in the skin and tendons. Type 2 collagen, a little bit different looking. You might see this in fibrocartilage, where it doesn't get compressed very well. Type 3 collagen is actually that type of collagen fiber, which is a reticular fiber. And then you can see there is a couple other ones here as well. Again, I'm not so worried that you know all these different types of collagen. Just realize collagen is not just this one type of fiber. It is multiple types to it that can have slightly different functions depending on what we're talking about. So again, type 1 cartilage is what we're mainly going to be talking about today here. We see this in the dermis, tendons, bones, fibrocartilage. We're going to see a lot of these things when we talk about it. It's going to be those fibroblasts that make it, or chondroblasts in terms of the cartilage. definitely pink in those H&E stains. Type 2 cartilage made by chondroblast in both hyaline and elastic cartilage. Very thin fibers. You don't see these ones particularly well. And then you can see in some of these other ones, your type 3 is a little bit more of those lymph nodes and things like that, which a lot of times we refer to as reticular fibers. These are ones that we do a silver stain to see. We'll talk about reticular tissue, reticular connective tissue in a little bit. It is really going to be that type 3 type of fiber. So you can see here cross sections as well as longitudinal views of them by electron microscope. But again, if you look at the actual structure, it's almost like a braided rope. Again, braided rope's really good at tensile strength. So if you have like a rope, you pull on the ends of it, it's quite strong. That is what I mean by tensile strength. Again, we put a lot of these fibers in a number of different places. They are going to resist that stretching of that. So like with a tendon, you pull on the ends of the tendon. It pulls, the muscle pulls on the tendon, which pulls on the bone. It doesn't stretch out a ton. It is able to take that stretch, that pull on it though, and resist it well and provide strength. Again, it is an eosinophilic type of stain. You can see these collagen fibers in this image here are all these pink things here. That is that type 1 collagen. We'll see this type a little bit later on. This one has fibers going in a lot of different directions, which is why you don't see any distinct fibers too much. You can kind of see longitudinally right here, but like this right here, it's actually a cross section right through the end of the fiber. And again, the fibroblasts being pointed at by these arrows, those are what are going to be a lot of times making the stuff that makes up the matrix. So those different proteoglycans, aminoglycans, and things like that. You can see the collagen fibers are these pink, broad things traveling through this. Reticular fibers, like I said, they make networks a lot of times in lymphatic vessels. They are stainable with a silver stain is what really makes those pop, and those will be this black background type of stain with these reticular fibers. And you can see some of these tissues will have them in multiple areas. You can see this one has collagen as well as elastic fibers. Elastic fibers, and this is a type of connective tissue we'll talk about in a little bit called areolar connective tissue. It has a decent amount of both, but you can see the collagen fibers are the wider pink fibers. Elastic fibers are a little bit more hematoxin, so a little bit more basophilic, and they tend to take on that purple stain a lot more. And you can see these elastic fibers in this image right here. Like I said, the ground substance is this background area, which is going to be having these different dissolved proteins and other things in there. It's kind of a gel liquid. Fills the space in between these cells and these fibers, helps hold in fibers and other stuff in there. Generally, ground substance does not stain unless you are doing a particular stain to stain for something in it. So it usually is going to be kind of white or clear in these tissue sections. But it is a combination, like I said, of kind of some of these sugar proteins, so proteoglycans, glycoproteins, glycosaminoglycans. Some of these glycoproteins are things like fibronectin and laminin. Sometimes these do play a role in terms of how the epithelial cells might grow through the tissue. It helps maybe sometimes direct these. There is some signaling that takes place with this. Again, I'm not going to ask you specifically about fibronectin or laminin. I just want you to know that these are some of the things that are some of these glycoproteins that may be important here. Again, laminin helps stick it to that basal lamina, the epithelial cells. And again, important in cell differentiation. These a lot of times give some signals to some of these other tissue types. The interstitial fluid that these are dissolved in is that tissue fluid. This is really a blood filtrate. So blood pressure pushes some watery stuff out. It's a blood filtrate, mainly water, but with some other components mixed into it. This sooner or later is going to enter back into a lymphatic vessel. At that point, we call it lymph, but it is kind of the circuit where it's going to get into this tissue spaces, get back to the lymphatic vessel, goes back to the bloodstream, and then sooner or later gets pushed back out of the bloodstream in the capillaries, out into the tissues, and we do it all over again. So what are connective tissues doing? I mean, the obvious thing here, connecting. Try not to be a smart aleck too much, but really a lot of these connective tissues are very structural. they are providing fibers and ground substance. This is going to house the cells. In some cases, it's a lot of fibers, which can be very structural when you think about tendons or ligaments, as well as loosely attaching certain other tissues to ones beneath. We're going to see blood is involved in immune protection, so the white blood cells. So definitely an immune response there. Adipocytes can store lipids. Lipids are a way of storing excess calories. So we can also store energy and provide insulation with some of these connective tissues. If we start looking at some of the specific cells of this, to me, it's really two main classes that I would say here. The upper part here, if we start talking about the connective tissue producing cells, these are going to be fibroblasts in more of this fibrous connective tissue, chondroblasts if we're talking about cartilage, osteoblasts if we're talking about bone, odontoblasts if you want to talk about teeth. We're not going to look at teeth, but that's what an odontoblast is. The main thing in these ones, the fibroblasts in the fibrous connective tissue are going to make the fibers in the ground substance. In chondroblasts, they are making that more rubbery matrix and the fibers that are in that. In the case of bone, it is releasing the osteoid, which is going to be those, again, fibers, as well as those calcium salts, which are going to form together to make the hard substance called hydroxyapatite, which makes up bone. So when we really think about this, these are doing that production of the fibers in the ground substance, really making that connective tissue, where the rest of these are all cells of immunity, and these are all different types of blood cells or blood cells that have left circulation. So neutrophils are blood cells, macrophages are a monocyte which has left the tissues. You're going to have lymphocytes, type of white blood cell, plasma cells, a differentiated lymphocyte is what that is. Then you got the eosinophils, basophils, and mast cells. These are all inflammatory triggering cells, which again, part of the immune system. So these bottom 5 groups here are all involved in immune response. So we really have those producing cells. The other thing we'll see on some of these ones, you will start talking about cells that get trapped in the matrix. You might say chondrocyte or osteocyte or odontocyte. So those are the different things we're looking at here. Connective tissues start out as kind of undifferentiated, unspecialized connective tissue. So a lot of times we'll talk about mesenchymal tissue or embryonic connective tissue. These are going to have kind of fibroblasts in a background substance here. These mesenchymal cells are fibroblasts in this kind of substance, background substance. So it looks something like this. Very undifferentiated, very indistinct. You can see these cells hanging out in pretty much a white background. That is that embryonic connective tissue or mesenchymal tissue. Another type of embryonic connective tissue is what's called mucous tissue. This is really seen in kind of a later stage here. I believe, if I remember correctly, this is something you see a lot of times in the umbilical cord. But again, another type here. Again, these two, I just want you to know they exist. We're not going to be looking at them. We're not going to be identifying these two types. But this is what a lot of your other different connective tissues are going to come from. And the main thing, these undifferentiated mesenchymal cells can become fibroblasts, which are going to be important for making connective tissue proper. Chondroblasts, which are going to be important for cartilage, which sooner or later become chondrocytes. They can also become osteoblasts, which sooner or later make enough bone that they become osteocytes. They can also differentiate to adipocytes or fat cells. So these are all different things that these mesenchymal cells or embryonic connective tissues can become. And again, the main tissue cell when we're talking about fibrous connective tissue is going to be the fibroblast. It actually means fat making, not fiber making. It would be better if it meant fiber making, but it doesn't. But these are these spindle-shaped cells, so wider in the center, going out to the points here, tapering on the ends. They are going to make the collagen fibers. They are going to make the elastic fibers. They make the glucosaminoglycans, the proteoglycans, the glycoproteins that are going to really become the other components of these particular connective tissues. So you can see a couple of them in here. Really, most of the cells you're going to see in these fibrous connective tissues will be fibroblasts. They're really kind of hard to see distinctly. Again, the main thing you can see is the nucleus in a lot of So really, those are the cells, the fiber types, the different things that make up the ground substance. What we're going to do in the second half of this one is we're going to go through the different types of fibrous connective tissues, both loose and dense types of connective tissue. At the end of that, I will give you a little, again, slide looking at some of the digitized slides to show you and highlight some of the different types of this and how to differentiate them from one another. So I will see you later.